Dr. G Academy.
Before getting started, I would like to go through some basic theory that you might find useful in order to understand the exercise that we'll do later on. The Poisson distribution is the discrete probability distribution of the number of events occurring in a given time period, given the average number of times the event occurs over that time period. In order for the Poisson distribution to be a good model, the events must occur singly in space or time, independently. In other words, if an event occurs, it does not affect the probability of another event occurring in the same time period. And finally, the rate of occurrence is constant. That is, the rate does not change based on time. In the following exercise, we will also be using the binomial distribution. I'm assuming that you already have this basic knowledge. If not, I've briefly gone through how to apply it in this exercise. Okay, let's get started by reading the statement of this problem. It says, Beatrix has been selling flowers at a rate of 1.8 per day. Let's make f the number of flowers Beatrix sells in a day. We're going to model the variable f using a Poisson distribution with parameter 1.8. Because the Poisson distribution is used to model the number of times, or in this case, the number of flowers sold within a given interval of time or space. Question I says, find the probability that in a particular day she sells no flowers. In other terms, the probability that f is 0. We're going to use the formula that's marked in red that states that whenever we're using a Poisson distribution and we're looking at the probability that x equals a certain value that x can take, we can find out this probability by applying this formula. Therefore, the probability that f is 0 is equivalent to e to the power of minus 1.8 times 1.8 to the power of 0 divided by 0 factorial. That equals 0.1653 to 4 decimal places for a more accurate result. The next question says, find the probability that in a particular day she sells 3 flowers. In other terms, the probability that f is 3. And by using the formula marked in red, this is equivalent to e to the power of minus 1.8 times 1.8 to the power of 3 divided by 3 factorial, that equals 0.1607 to 4 decimal places. Following the previous question, I says, find the probability that in a particular day she sells at least 3 flowers. In other terms, the probability that f is greater or equal to 3, that is equivalent to 1 minus the probability that f is less or equal to 2. To find out the probability that f is smaller or equal to 2, we have to look at the Poisson cumulative distribution function tables. In this case, the parameter is 1.8, and so the probability that f is smaller or equal to 2 is 0.7306. Alternatively, we could also find out this value by using our calculator. 1 minus 0.7306 is 0.2694, hence the probability that f is greater or equal to 3 is 0.2694. Great, now let's read part B. It says, find the probability that over a period of 4 consecutive days she meets her daily target exactly once. Given that Beatrix meets her daily target if she sells at least 3 flowers in one day. Let x be the number of days where she meets her daily target over a period of 4 days. As you can see, after formulating our hypothesis test for x, the suitable model for x is the binomial distribution. Therefore, we're going to binomially distribute x with index 4, the fixed number of trials, in this case 4 days, and the parameter 0.2694, the fixed probability of success. That's a probability that Beatrix sells at least 3 flowers in a particular day. If you're wondering, this is our result from the previous part. Again, the statement tells us to find the probability that she meets her daily target exactly once. That's really the same as the probability that x equals 1. We will now apply the probability mass function formula of the binomial distribution. N, sometimes called as the index, is 4. The number of successful trials, k, is 1. And as we said before, p, the probability of success, is 0.2694. Once we've substituted the data into the equation, we get that the probability that over a period of 4 consecutive days, Beatrix meets her daily target exactly once is 0.4202. We've reached the end of the video. If you have any queries, please feel free to comment down below.
Dr. G Academy.